And so then you can go actually, one of the problems with the astronomical solution, for instance, is what we call the chaotic behavior of the solar system. And so you know the chaotic behavior from, that's why weather is so very difficult to predict, and the sensitivity to initial conditions. So at a certain moment, beyond 50 million years, you don't know anymore what solution is reliable. So then what the astronomers can do, they generate maybe 10 or 20 or maybe even more solutions with very small changes in the beginning. They calculate all these solutions and then they can see what solution has the best fit with our data.
Wow.
And that is then probably the solution that is the most reliable.
I could imagine that taking those solutions provides a lot of trial and error situations. How did you cope with actually all your errors? Like, what did you do to make it fun?
Yeah, so to remove the errors is, let's say, we apply what we call integrated stratigraphy. And so you apply all the different stratigraphic methods to get, because you need an initial age model for the cycles that is as good as possible. So the initial age model is then based on the combination of magnetostratigraphy and biostratigraphy or radioisotopic dating. And once you have that initial age model, then you can start this kind of what we call the tuning exercise, to correlate the cycles to the astronomical target curves. But it really depends.
So basically linking the rocks with.
But it really depends on the accuracy of your initial age model. And that's also the fun, so that's what I like very much. It's really interdisciplinary. So you also have to bring together, for instance, the astronomical dating community with the argon-argon and uranium-lead dating community. Because let's say if our standard geological timescale is based for the main part on these three methods. So if you date the same event, you should in principle arrive at the same age. But that was not always the case. So that's another issue we are working on. So that are the nice issues. You can work on these for basically decades because you solve them step by step. It takes a long time. And that's one of the things we are still working on, but we are getting very, very close, I would say.